the table of content first. We are still in chapter 18, paging introduction here, and still on homework simulation. Let me open that. Okay, we are still on this section, basically trying out this Python script about translating virtual to physical trace with linear page table. We had to take a look at question 1, had to take a look at question 2, and now we are in question 3. To be precise, trying out this configuration with the Python script. Okay, let me open that. Okay, let me try translating the virtual trace to physical trace. Then 1K, 16K, physical trace 32K, verbose, and then percentage usage of the virtual trace is 25%. Something like this. Okay, let me take a note. What should we do first? Okay, we should get the, what is it called? The virtual trace for the virtual page number. Get virtual page number, and then get page frame number, get offset, get physical address. Maybe something like this. Wait a minute. Be right back. Let's continue. Assuming we have this one, virtual address, okay, and then wait a minute. Let me get the information of page marks, right? The page marks in this case, because we have the page size 1K, basically what is it called? 1024, and in this case the patch match is what is it, 1024 and -1. Not that I think about it. Why do we need to -1? Maybe, maybe the, what is it called? The maximum size in one page, something like that. So basically, in the page, in the virtual page number 0, it is something like this, right? So maybe that's why we need to -1. Okay, and then virtual page mark, this one. I think the virtual page mark, yeah, VPN max. Let me check here. Okay, yeah, let's put this, I guess. VPN max or virtual page max, and then the page speed is actually, yeah, import net. I think 10, right? Base 2, okay, 10. Bit, alright. Okay, so we do this first. Remove, what is it called? We are doing the masking here. Basically remove the offset bits, right? Okay. Get this one, okay. Getting the, what is it called? Base virtual page, something like that. Okay. So let's assume we have this one. And the page match, okay. Be something like this. Oh, VPN max. Okay. Wait a minute. Or something like this. Okay. VPN max. This one. 14. And then page 14 is 0, I guess. Right. Okay. Alright, so this is invalid. I'll test this one. I mean, I can take a look at this table. Where is it? This one. To find out where this reside to, right? Looks like this is in this one, page virtual page 10, and I also can what is it called, calculate like this. Okay, 10. And then after this is valid, we get the page frame number. I think we remove this, right? And just get this. Okay. Page frame number is 24. And then after getting the page frame number, we are getting the offset. The offset is something like this, I guess. Page frame number plus offset. Okay, and then using the right shift here, right, is it 24 or 19? If I remember correctly, it is 19, but yeah, let me check again. Oh, wait, No, not that one. This one. Okay. Okay, 19. Yeah, not 24, but 19 here, and then $19, and then there's the offset. Need to do this, right? We get the, what is it called? The base physical trace for this patch frame. Maybe something like, something like this, right? And then I think that with the offset. Okay. Okay, something like that. And then virtual address. This one. Okay, something like this. Maybe we can change this. Okay, maybe. And call this so if I change the VA into this one, okay. Okay. Virtual page number 7. Page frame number. Oh, invalid again. Okay. Invalid. And then this one. Okay, page frame, virtual page number, I mean. One page frame number. Okay, is invalid. To trace this this one. Six, and then 6 is invalid again. Okay, if I remember correctly, something like this. So let's check. Right, only one that is valid. Now I'm kind of curious if we change this to, let's say, 2 megabyte. Oh wait, right, this is this change. Oh. Let me try this. Wait. Be right back. Okay. Finally, this one. Oh, I mean, okay. Okay, 1552. Okay, right. Let me try calculate this. Okay. Is this correct? Let me check. Okay. Alright. Looks like this is the same. Okay, let me check for this one, because we changed the page, the physical memory size. The result also changed, I guess. Okay, so it is this one, right? I mean, previously it is 19. Okay, this one 19. And now it is 1269. I mean, yeah, the physical test that I try is 2 megabyte, so something like that. And then the offset, I think the offset is the same. I mean, we didn't change the virtual address and also the page size, so the page match sheet still the same, I assume. Okay, let me try this. Yeah, getting the base address for this physical frame or page frame, I guess, and then using OR bitwise operation at the offset. Oh, okay. So instead of 20,422, we got this one. Let's see if it is correct. One two nine 7,350. Okay. Alright. Let me put this in here. Representation. Yeah, to make this easier to understand. Simulation. Presentation. Hello Anna Wines. Is it rainy season again? I'm not sure, but sometimes it rains, sometimes it's not. So the what is it called? The weather is inconsistent, I guess. So I'm not sure if it is rainy season again. Yeah, let me. Okay. I did type that out. Yeah, there's a lot to get, I guess. Okay, anyway, let's try continue into this one with the percentage usage 50. Yeah, 50% of use. And of course we are using physical memory size 2 megabyte. Alright. Okay. Yeah, Okay, first thing first, we need to get the virtual page number. Okay, yeah, virtual page number and the, what is it called? Oh, I mean virtual address, right? Virtual address with the masking. Yeah, because the page size still 1K, the masking should be the same. This one, right? Okay. Wait, I cannot forget. Oh, right. We need to use right shift. Okay. Right shift to. Okay, with the bits. I think I already used that. Right, oh, okay. Yeah, maybe next time. Virtual page number 6. Wait, let me calculate this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So virtual page number 6, this one. Alright. Wait. Okay. Page frame number is this one. Because again, like order or leftmost bit is the valid bit. So if we doing something like this, this is the valid bit and the rest is the page frame number. That's why it becomes something like this, right? Okay. I'm not sure if we can remove this one to get the page frame number, or we need to use the binary representation here. That's something I'm not sure yet. But yeah, it is the leftmost bit. We are removing the leftmost bit to get the page frame number. Okay, page frame number this one. And then the offset is, I think the offset is still 966 because the offset depends on the page match. Okay. Oh, no. Not 966 yet. 966 is for the, what is it called? The virtual address, this one. It's not 966 anymore, so we should calculate that. Using the masking here, basically removing the, what is it called? The virtual page number bit, something like that. And then this one, again, the page match is the page bit, right? And then negative one. I'm assuming this is because the page match is the largest address in one page. I mean, if we think about this, let's say we have page size this one, in the page 0 we will have 0 until 1023, something like this. So this is the page match, maybe something like that, which can be wrong. Okay, oh, 696, and then yeah, already this should be something like this. This 9, left shift 10, right? We need to get the base address for this page frame. Okay. Right, and then using the bitwise operation or with the offset, basically adding the offset here. Okay, this one. Alright. Nine 969 becoming this one. Okay, this is the first one here. Let's try this one again. Yeah, there is a lot. Virtual page number. The masking is something like this. 9, okay. Yeah, I don't necessarily remember this. The virtual page number max, you know, this one. Basically this max is to, what is it called, removing the bits, the offset bits, something like that. If we take a look, yeah, it is something like this. We only getting this virtual page number bit and we are removing this one. And then we do the, what is it called, the right shift to get the virtual page number, something like that. Okay, and then virtual page number 9. Oh, okay, this is invalid. Okay, let's continue into the third one here. Okay, 14. 14. The page number 14. And then this one. Okay. Nine, 6, 6. Is that it? Let me check that. Okay. Oh, okay. Oh, yes, bro. So it's easy to catch a cold, right? Yes. Still stuck on VM patching. The discussion is heavy, right? Well, it is. What is it called? I'm not sure if this is heavy, but this might be confusing for the first timer, I guess. For someone who completely new how this works. What is it called? The translation from virtual address to physical address with linear page table. And again, we are still using the linear page table. I assume there are non-linear page table. Maybe after this, I'm not sure yet. But yeah, it can be quite confusing for anyone new. Is this Linux? Yes, this is Linux. I'm not building anything. I'm reading this book, Operating System to Easy Piece. Basically trying to understand the operating system concept. And currently I am on chapter 18, learning about patching, the introduction, and checking out the homework simulation here. So yeah, I'm not building anything yet at the moment. And then the offset, right? I always forgot how do we get the offset. Okay, virtual address, max with the page max. Guess okay. Something like this. Yeah, all of this is in binary, not in decimal, in case anyone wondering. And this 10 is from, I think this one, address space size. So basically if we use this to power 10, oh, okay, yeah, I think this one, the page size, not the, what is it, not the address space. So there is that. Is anyone wondering why this is 10? Yeah, sometimes I get confused which one is from the page size and which one from the address space. Oh, maybe something like this. Okay. Oh, but no, I don't think so. Yeah, this one. This is the address space. 16K. So yeah, the 10 here means this is in one page. The offset in one page, I guess, maybe something like that. So we have 10 bit as the offset bit and 14 bit as the entire address bit. Maybe we can note this like 10 bits is the, what is it called? The offset bits from bit size, and then 14 bits the entire address bits from address space size. Yeah, something like this. Okay, and then we add that with the offset here. Okay. Something like this for the physical address, right? Okay, yeah. So from this virtual address, we translate that to this physical address in the physical memory. Something like that. And then let's continue to this one. Virtual page number. Okay. 15. Yeah, again, I don't really remember the virtual page number max, and it is a lot. Let's put it that way. So there is that, and we are right shift divide by 2 power 10, something like that. Okay, 15, and this is invalid. Okay, if we got 0 here, R0, it is invalid. And then let's continue to the last one here. The address, okay. Not that one. 7. Let's see. Okay, this is not invalid. Let's get the page frame number 577. Oh, interesting. Wait, physical memory is 2 megabyte, right? Okay. And then the offset for that. Okay, something like this. Oh. Okay. We get the page frame number here. offset here. So something like this. What is the offset? Okay, wait a minute. Five. Okay, maybe something like that. Let's see if my calculation is correct or not. Alright. Let me remove this. Okay. Virtual page number 6. Alright. Yeah, this one. And then 1904585. Okay. This is invalid. Virtual page number 9 not valid. Okay. And then this one is 990. Oh, okay. Looks like this is incorrect. Okay. Interesting. But yeah, let me incorrect. This is invalid. Okay, but this is correct. Interesting. What is wrong there? 591495. Did I not get the right virtual page number? Oh, maybe. Let me check here. No. Or maybe we should use the binary representation like this. Oh, I mean, yeah. That's correct. So what is incorrect here? Is it the offset? Maybe 958 masking that with this one, the page mark. Okay. Interesting. Let me print it again. How is this? Okay. 622, right? 966 here. The bits are so 10. So what is the problem here? is interesting. Oh, wait. Right. I should have used the offset here. Okay. Alright. My bad. Wait. 989806. Okay. Yeah, my mistake is this one. Instead of using offset, I'm using the page frame number here. Okay. I really want to add another option to print out this one as a cross check, but well, maybe next time. Okay, the use percentage here. Hello Asad Umar, welcome. We are currently reading this book called Operating System 3 Easy Piece, and currently on chapter 18, learning about the patching, what is it called? Patching memory stuff, I guess. Basically learning about virtual memory with the patching technique. Maybe that's more like it. That's the better explanation. I'm learning about virtual memory with the patching technique, and currently on homework simulation section here, and we are taking a look at a script, a simulation script, to learn how the virtual memory or virtual address translate to the physical address with the patching technique and the linear page table, something like that. And we are on question 3 now, basically trying to translate this one, trying to translate the virtual address with the virtual address to the physical address if it is valid, which means there might be some invalid virtual address too, something like this. And long story short, the invalid one basically means that we haven't have the, what is it called, the physical address connected to the virtual address here, something like that. Okay, I think let's continue this. Yeah, previously we tried out using the percentage usage 50, basically 50% from the total page that we have. In this case we have 16 pages, right? So 50% from this, I assume, is used, something like that. And let's continue this one using this configuration on the next session. So that's it for now. Thank you for watching and see you next time. Bye bye.